we have this truss right here, and we're gonna try to solve using one free body diagram, two by creating vector components at for any force that is at an angle, three finding the sum of all forces in the x and in the y directions, and then finally by being able to just solve those equations that we end up with. So we have point A, B, and C. Something to note in here is that at point A we have a pin, and you gotta remember that for a pin we have two reactions, and point B we have a roller, and in that case we only have one reaction. Okay, so I'm gonna start at point A. And so point A, I'm gonna put it here. Let me just put that in there. So point A, we have four forces. As I mentioned first, it is a pin, and by default we are going to have AY and we are going to have AX. Then we have this force coming down, which is force AC, and we also have this force in here coming this direction. That is actually supposed to be horizontal. Yeah, there you go. And this is going to be force AB. One of the questions that we've been getting in class is, how do I know what direction I put? That for us in this class, it doesn't really matter. Just keep in mind that if you do get a negative value, that just meant that the direction was supposed to be in the opposite direction, and that's fine. Just carry that negative value all the way through. Do not try to change anything. Keep it as it is. Okay. Um, Going with my second rule in here is to break into vector components any diagonal force that I have. In this case, I have force AC. Also keep in mind that we have 30 and 60 degrees Celsius. So then I'm just gonna grab it and put it over here. Okay, and this is going to be my Y component, and this is going to be my X component. And once I start working with them, they're both going to be negative because this is going downwards and this is going to the left. Okay. So I am going to use a sine. I have enough space. I'm gonna use a sine of 30. Oh, and let me do something. Let me just bring this just a bit lower. So I'm gonna have a sine of 30 is equal to y. Okay. Because you gotta remember, sine is opposite over hypotenuse. So opposite of this here is the y, and the hypotenuse is going to be force AC. Had I chosen the 60 degrees, opposite side would have been this one. Okay, but we are working with the 30-degree angle, and this is my X component right there. Again, so sine of 30 is opposite over hypotenuse. In this case is force AC. Since I want to isolate the y, I have to multiply both sides of the equation by force AC. Now what happens is that this cancels out, and I end up with force AC sine of 30 is equal to y. We are going to essentially apply the same thing for cosine. So cosine of 30 is equal to x over the hypotenuse. And I already know that the same procedure is going to happen, and I am going to end up with force AC on this side over here. Okay. Now I can do the sum of both forces in the x direction. Don't forget to set it equal to 0. We don't want things to be moving around. The reason why we set this equal to 0. Okay. So things that move along the x-axis are three things. If you want to think about it like this, okay, this being your x and y coordinate system, okay, you have one, you have force AB, and you have AX, which move along the x-axis, and you also have this here, which is part of your x component. So I'm gonna put all of those together. Keeping in mind that AX goes to the right, which makes it positive. Force AB is moving towards the left, which makes it negative. This X component is also moving to the left, which makes it negative. So the way I'm gonna set all of this up is AX is positive, uh, minus force AB, okay, minus force AC, cosine of 30, and it's supposed to equal 0. Now I am going to do the sum of both forces in the y direction. So things that move along the y are just two, which is AY and in this component right there. AY goes up, and the y component for this one is moving downwards, which makes it negative. So in this case, I'm gonna have positive AY minus force AC sine of 30, and that is equal to 0. At this point, I can't solve for anything because I don't know what AX is equal to, force AB or force AC. So I'm just gonna leave it as that. I am going to continue with the free body diagram at point B. Just like I mentioned at the beginning, a roller has only one reaction. So at point B, I'm gonna have By, okay, going up, and then I'm gonna have force AB, and in this case, the reason why I'm gonna draw it in that direction is because I already have it over here, so I wanna keep things the same. And I also have force CB, and I can actually draw this one coming down right here. So force CB, okay, and I would do the sum of all forces in the x direction, and again I'm gonna set it equal to 0. In this case, I only have one force, which is force AB, which moves along the x-axis. And so then when I put it, force, oh, and that's negative force AB equals 0. And there's nothing else that I can put it together with. So then force AB is just equal to 0 newtons. So we already found one of them. Do I have any place that I can plug it in? Yeah. So force AB in this case is gonna equal to 0. So I'll come back to it later on once I find more information. And so I will now do the sum of all forces in the y direction. And again, I need to set it equal to 0. I have force CB going downwards, so that's going to be negative force ZB. And then I have BY going up, which is equal to 0. And next, what I want to do, I want to move this from this side of the equation to the other side of the equation. Cancels out, so By is equal to force CB. Again, I don't know what any of these are equal to just yet. So I'm gonna keep moving forward, and I will now do a free body diagram at point C. Point C, I have three reactions only. I have force CB, which is this one. I have force AC, and then I have these 300 newtons. Okay. So then at point C, like I said, I have 300 newtons going in this direction. and I have force AC going in that direction, and I have this force going in that direction. Again, notice what I did. Since I already had this force AC going downwards, this one right here, I'm gonna use the same direction over here. And since I also had force CB, which is here, I'm gonna use the same one right here. Okay, I don't want to change anything just in case I mess up, and that's something that I don't want to do. I can easily break this one into its vector components, but I don't have to because I already did that step in here. And I'm just gonna use the same x and y components. Okay, so then what I would do is that I'm gonna do the sum of all forces in the x direction, and again they have to equal to 0. In this case, I have these 300 newtons going towards the right, so that is positive, so I'm gonna have 300. And then I have the x component of this force AC, which is this one, and that is negative, so that's going to be minus force AC cosine of 30, and that is equal to 0. I'm gonna move this whole thing from this side of the question to the other side, and I do so by adding that, and I'm just gonna skip that step. It's just simple algebra. So okay, fine. I will go ahead and do this step, but I will be skipping this step later on. So what I'm gonna do is that I'm gonna have plus force AC cosine of 30 from that side of the question, and you gotta remember, whatever you do on one side of the equation, you have to do it on the other side of the equation. So that is going to be plus force AC cosine of 30. In this case, this cancel out and end up with 300 equals to force AC cosine of 30. So now I'm gonna divide by cosine of 30 both sides of the equation. So force AC is going to equal to, once I plug this in into the calculator, I'm gonna get 346.41 newtons. Okay, now I'm gonna do the sum of all forces moving along the y-axis, and it has to equal to 0. In this case, I have force CB going downwards, so I'm gonna have minus force CB, and then I'm gonna use this y component over here, and that is also moving downwards, so it's going to be minus force AC sine of 30 is equal to 0. Okay. I am going to move this 4CB to this side of the equation by adding it to both sides, and so then I am going to end up with force AC sine of 30 is equal to positive force CB. I already know what force AC is equal to, and so then I can just substitute into this right here to find the value of force CB, and so then that is going to be 346.41 negative times the sine of 30, and that is going to equal to the force CB. And so then once you do that on the calculator, you should get 173.205, and we can actually just round it off to 173.21. Okay, So we found force AC, we found force CB, and we can actually come back to this right here, because we already know what force CB is equal to, and we just plug it in there. And so then force CB, we know that is equal to 173.21 newtons. By equals 173.21 newtons. Okay. Is there anything else that I can find? No, that's pretty much it. So now I can go back to this equations over here. So in this case, notice we already found what force AC is equal to. We can plug it in there. We found what force AB is equal to. We had said that that's equal to 0. So this here will just go to 0. And we again, we found what force AC is equal to. We'll plug it into that. That would essentially give us the value for AY and AX. And like always, just double check my work and make sure that you do end up getting the same values that I'm getting. Okay. So then let me see. By, we know that we got 173. Okay, that's good. So now we are just going to plug in the rest of the values into the next equations. Okay. Let me just erase a couple of things in this case here. I'm gonna move this force AC cosine of 30 from this side of the equation to the other side of the equation. And knowing that force AB is equal to 0 makes this a lot easier. So then AX is just equal to force AC cosine of 30. Okay. So AX is equal to force AC. Again, force AC turned out to be 346.41. 346.41 times cosine of 30. So then AX, once we plug in this into the calculator, we end up having a value of, let me just double check. I have it over here. Let's see. By, let me actually just do it. So then 346 times cosine of 30 is going to give us 299, which makes sense. So I'm just round it off to 300 newtons. Okay. And so then now we can do the same thing over here. So we have that AX equals to 300 newtons. And so then now I'm just going to plug it in into the other one, which is in here, but I want to move it to the other side of the equation. So then AY is equal to force AC sine of 30. So AY equals to 346.41 times the sine of 30. So then AY is equal to, let me just double check, 346.41 times the sine of 30 is equal to 173.21. I'm gonna round it off. Okay. And so then we have found every single value that we needed. In this case, we found AY, we found AX, we found force AC, we found force AB, um, if I'm forced BC and BY as well. So quick but straightforward practice problem. I hope this helps. Yeah.